two PowerPoints. One is out of the book, and the other is the other is right out of the from my class. And I didn't like the book one as much because I felt that aside from a couple of the schematics not being correct, I just didn't like the breakdown as much on it. So I elected to use mine because I just think it's a better layout. So that's why we're using this one, but I did post them both up. Certainly if anyone has any questions on the one that's in the book, I can answer those. And either privately or next time we get together. Also, I uploaded mine and it has a lot of notes in it. So it's covering things that are not necessarily going to be in the book. So I wanted to make sure I covered that also. So automotive networks. Oops. So for many years, vehicle manufacturers have added new features to their vehicles, had to accommodate more sensors, actuators, and wiring to accommodate these new features. These additions added more complexity to the vehicle, required larger and more expensive central computers. Well, what we've done on vehicles is instead of having one central computer, we have a lot of, as we learned yesterday, nodes or a lot of different computers on a network. So if we need to use a lot of computing power, I could put them together, basically use them as bots to do larger computing problems. But what it does is it allows a lot of redundancy. So if I have a problem with one module, I'm only going to lose a certain part of the vehicle. I'm not going to lose everything. So it made it much safer. Also, the cost of production was lower because not every car gets every option. So that way we could put the options on the vehicle that customer bought or at the trim level that customer purchased, and yet allow them to work together to do these complex problems. So that also kept costs down for customers. So for example, before electric cooling fans were first controlled by the PCM, it was not uncommon for the engine to have 3 coolant temperature sensors or switches. One for the coolant temperature sensor input to the PCM, one for the electric cooling fan input, and one for the temperature warning light or gauge. As a matter of fact, when I was back in Virginia at my daughter's wedding, I was staying at her house and her fiance's car, the fans didn't work. And his car, being a 98, had all 3 of these different sensors. So even as little as 20 years ago, these systems weren't networked. It had 3 different sensors. It had one for the gauge, it had one for the computer, and it had one for the fans. So 3 different things. Newer cars, we only need one, and we network it. So these extra sensor switches were redundant, added weight, which meant less fuel economy, and to the vehicle, and added more potential for system failures because of more connections. The more connections you have, the more connections that are going to go bad. To eliminate these problems, manufacturers changed to a network system. So in here, I put in questions. A network system can use a single sensor for many modules that need the same information. So I want you to keep your answers to yourself right now. I'm going to get to 10 of these and I'm going to poll you. So go ahead and make notes, and I'll give everyone a second to get something to write down on. Make notes as we're going through on what your answer is for each of these. And I'm going to poll all of us all at once. Because with this system, I can't ask the questions one at a time. I got to open up the whole poll at once.
This is like question number 1.
This is question number 1. You got it. So we're going to get to 10 questions, and then I do a poll. So I'm going to rely on you guys to let me know when I get to the 10th question, because I don't have them numbered on here and I'll lose track. You know how forgetful I am.
Wait, sorry, I'm kind of late to this. What are we doing?
You're going to write down your answer to each of these questions. This is question 1. We're going to get up to 10 questions, and then I'm going to open up a poll and let all of you answer.
Okay, cool.
Instead of just everyone chime in, so that way we get some feedback.
Done.
Where should we write the answers?
Just on a piece of paper.
Oh, okay.
Yeah, just put question one and put your answer you want. You can write down the whole question. If you want, you don't need to because this PowerPoint's on Canvas, so you don't need to, but just write down what your answer is for each question. It's probably the easiest way to do it. We ready?
Ready.
Yes, sir.
Yep, I'm good to go.
Yes.
Okay, so when we look at network strategies, we can see there's a lot of modules that we can have on a vehicle. And we talked about how modern vehicles can have 160, 170 different computers. And here we look at some of these systems. We got our night vision that we talked about yesterday. I have electric power steering, electronic throttle control, blind spot detection, active suspension, security systems, not to mention my engine, my transmission, my automatic braking, my airbags. So we have all these modules. I don't want to put all these on one network. And like I talked about yesterday, we're going to want to use different networks because not all these modules need to work at the same speed. So I don't need to invest the same amount of money into every network, as well as some of these modules are probably more important than others. For example, I'm guessing that my automatic braking might be more important than my tire pressure monitor. It might need to get information at a much faster speed and send information out at a much faster speed. Is that a fair guess?
Yeah.
Yeah.
So,
Yeah.
right. So I don't necessarily want my low speed devices on my high speed network, as well as once I get things on a network, I need to have some way of controlling traffic. So we're going to look at both of those things. So we have a local area network. Now, a local area network is more a function of a framework, not a communication protocol. So I don't want anyone confused. LAN, local area network, can be a lot of different types of networks. So it talked in the book about CAN, it talked about most, it talked about different kinds of networks. Any of those could be a local area network. And then it depends on what communication protocol or what language that network uses. So here we're just going to use a generic LAN term to get the concept of what a local network is. So this eliminates hardwiring of sensors and actuators to every component, such as the PCM, the warning lights, fans, and et cetera, which results in lower production costs. So where I used to run a sensor that would go all the way from my fuel tank up to my instrument cluster to control a mechanical gauge like we learned yesterday, now I might put a module back in my trunk. That module is attached to my SEN unit. That module gets the signal from the SEN unit, puts it on the network, and then who needs to know that information? Well, the engine control module might need to know it. The instrument cluster needs to know it. So anyone who needs to know it is going to get that information. They don't all need to be wired to the sensor. So that way I can run a much shorter wire and go to the closest sensor that's on that network to get the information out very, very quickly, just as quickly as if it was on the same, going to the same module. So eliminates redundant components and wiring, which reduces vehicle weight, better fuel economy, reduces potential system failures from opens and shorts. Since there's less wiring and less connections, therefore we're going to have fewer issues. Information transfers faster between component systems. In other words, my transmission can share information with my engine, that can share information with my brakes or my steering. I can share things back and forth very, very quickly. So which of the following is an advantage of having a network system on a vehicle? And so you guys go ahead, that's question number 2. Go ahead and write that down. What your answer is. I'm getting vertigo watching Keith upside down.
Okay, can I put just number one and number
Yeah, you can put just the numbers if you
the
want.
two number? The
Yeah,
field,
whichever number you think the answer is for that question.
no, I will. Okay, thank you.
Because I'm going to bring them all up and they're ordered in the same way. Like I said, we're learning by doing. So we'll get there. All right, so let's get back to this. So network communication. So how does all that information get transferred in a single wire or two-wire network? Is there going to be a big traffic jam of information going to and from the modules? And here is obviously before we had street lights, and we had a lot fewer cars then, and look at the congestion. So there has to be an order, just like we have an order and rules when we're on the highway. There's an order and rules in the network, and those rules are defined by the network protocol. So for example, J1850 is going to have a different protocol than CAN, is going to have different rules than FlexRay, or different rules than MOST, or different rules than ISO 9141. These different networks have different rules, have different traffic rules. Just like sometimes if I go to different towns or different countries, I'm going to have different traffic rules. The one thing consistent is there's always rules, and with the rules we get order. And that's the key point. So in general, the system employs a data bus of one or two wires to carry individual information packets, sensor outputs, computer commands, etc., through the network system.
5 volts, right?
What's that?
5 volts.
Depends on the network.
Mm.
It can, and not all can, but high speed CAN C uses 5 volts and 2 wires. If I go to CAN A or CAN B, it might not do that. If I use FlexRay, it doesn't do that. So 5 volts is an arbitrary number that's used by CAN for that protocol. I got a case study coming up on a J1850 vehicle very shortly, which is GM's protocol. They call it class 2 data. And we're going to walk through diagnosing that vehicle, and it's not about fixing that car. It's about the thought process going through to fix a car.
It's like I say it's like indication, because actually it's it seems 1.8 to 4 something, right? If I remember right.
What's that on? What's the question?
It's an indication of 5 volts, but actually is like 1.8 to.
Oh, yeah, a CAN is a 5 volt scale, and we're going to get to that.
Right.
They use a 2.5 volt bias, and CAN high goes from 2.5 to 3.5, and CAN low goes from 2.5 to 1.5, and they mirror each other. I got some good lap scope captures coming up. The book actually did a really good job of showing that and explaining that part of it. Their information on CAN was pretty doggone good. FlexRay, their schematic was wrong on, and there was a couple other things and some of the background information. But I think the combination between what the book has and what I'm giving you, I think it's going to give you a pretty good understanding of how these systems work. And I thought they complemented each other, and that's why I chose to go this way with it.
Thank you.
So multiplex network system, think of this bus as a freeway, and with on-ramps and off-ramps to city, i.e. modules that can exchange information. So I have an information highway. I have stops on the highway, exits, in this case, a transmission module, an HVAC module, or a dash module. And that information package might be coded on how to get off it. Which modules do I need to stop at? Because I don't necessarily want to stop at every module. That wouldn't be efficient. A lot of modules don't care what a particular command is. So my commands are going to be addressed to who needs that information. For example, how much fuel I have in the tank is probably really important to my engine control module, but might not be as important to my transmission control module. It's really important to my instrument cluster module, but it might not be as important to my airbag module. So you see where different modules might be coded where they get certain pieces of information and are not required or don't understand or have any interest in other pieces of information. So that's how that's broken down in the system. So the information, and we're using the example of cars here, the information are actually transmitted in packets. So the cars are like information packets. Now, packet technology is a bundle of information. It was originally used in ham radio or an amateur radio, and we would send packet data to convey large piece of information. And it is, the entire packet is one piece of information. So instead of getting individual words, you were transmitting an entire concept or an entire group of information. And that's in the packet. So we use packets. The packets on our computerized system, because it's computer generated, have to be digital because a computer cannot generate an analog signal. So we send digital packets of information from one module to another along this highway. So the information on the network is carried in which of the following ways? And that should be an is, not an it. I apologize. That's what, question number 3?
Question 3.
Okay, I want to make sure I can still count to 3. I wasn't sure if I'd screwed it up.
I don't have a option here.
No, you don't have an option. You're supposed to be writing them down.
Oh.
And then when we get to 10, you guys are going to fill a poll in. So I want you to write your answers. Mario suggested just put it, you can put 1, 2, 3, 4 for each one. You can just write the answer down for each one, but you're going to number 1 through 10. And you're going to see the questions again and the answers, but this way you're not necessarily trying to go back that far. You know, it's a chance to kind of do it.
بعد ما يصير 10 أسئلة بيطلع لك بول على
شلون؟
اكتبون على ورقة هلا بعد ما يصير 10 أسئلة بيسألنا عن البرنامج.
There we go. Okay, so let's take a look at networks. We have different types of networks. This is a looped network here, and it gets the name loop network because it works in a loop, and there's certain advantages to a loop network. For example, if my instrument cluster goes bad, my HVAC module can still talk to my memory seat module through the radio. There's more than one path to get there. So one of the advantages of loop networks is if there's a break on any one wire or a break on any one module that information is going through, the rest of the network will still function properly, and it makes it really easy for the rest of the network to set codes. And those codes are normally what are called U codes or UART codes or network codes. And what their kind of codes you're going to get is if, say, in this example, my instrument cluster module stops working. I'm not going to get a code from my instrument cluster module. It's going to think everything is perfect. It's doing a great job. What I'm going to get is codes from my HVAC module and my memory seat module, and maybe even my radio module saying they tried to talk to the cluster module and he's not there. So in other words, in network, which is very different than we're working on powertrain management or transmissions, where we go to that module and we look at that module, what are the problems that that module sees? With network faults, we look at everybody else in the room and say, who messed up? Because if all the other modules are saying, hey, I tried to talk to the cluster module and cluster module didn't answer, but yet when cluster module comes back to work and I ask cluster module, is there a problem? Nope, everything's great. Kind of like when someone's sleeping in the class and when they wake up, they really don't realize they missed anything, but all of us do. Am I right?
Yeah.
So it's the same kind of thing. So if I have a module that's not participating, that module thinks everything's great. It doesn't realize it stopped participating. It's everybody else in the room, or in this case, everyone else on the network, that tells you or tells that module that, hey, we're setting codes because cluster was supposed to show up for work today and was gone for a half hour without permission. So that's where we're seeing those type of codes. Now, this is a very simple network. Here, I'm going to show you a Toyota network that's a little more complicated. And this is still a simplified version of a loop diagram. And it can be a little challenging. And this thing has some series and some loop to it. And I'm going to highlight some different parts of this network. And one of the things we look at on this, when we look at the network, is we look at the network topography. We look at how the network's built. Because if I have codes for several modules, or I have several modules I can't talk to, I need to look at the topography, and then I can usually figure out kind of where the problem is. And this happens to be very similar to the red Camry we have at school, that I can't talk to some of the modules, and I actually need to go in and fix that car. And this is actually a schematic very similar to that vehicle. I think it's 1 year off. So here, if I look in the upper right, I just turned it to yellow, and we're looking at the powertrain control module and the transmission control module. So the transmission control module only talks to the powertrain control module. Powertrain control module talks to the rest of the network. And where that blue wire is going out on the end is my diagnostic link connector. That's the pin that it talks to, right here. So this is my DLC right here. So it comes into my network, and it comes over, and what? I have the yellow here to my PCM and TCM. And then I also have another link here, which is dedicated where what? It leapfrogs between these. So these are not ringed networks. Those are series networks. They're what they're called daisy
Question,
chain.
what
Yeah.
DLC is, what's a DLC?
DLC, diagnostic link connector.
Oh,
That is
okay.
the 16-pin connector underneath the car that some people call an OBD2 connector. So that's the DLC.
So this is an OBD2 connector, right? I was about to ask that.
Well, no, it's a DLC. The reason why it's not an OBD2 connector is because the car, in this case, the car is OBD2, but there are cars out there that are not OBD2 that use the same connector. Because not all cars 96 and newer are OBD2. So, but all cars 96 and newer have that 16-pin DLC. Now, the scan tool manufacturer, and if I go on Google or whatever, they're going to tell me it's a LBD2 connector. They're wrong. It's a 16-pin diagnostic link connector because not all the cars it's connected to are OBD2. So you see the fine difference that I'm splitting there?
Yeah. So each manufacturer can have their own, I guess, OBD2 type sensor or scanner or something, or what?
Yeah, each manufacturer has their own scanner. There is two parts to the system. One part of the system, if the car is OBD2, it has to talk on a certain protocol line. And then the manufacturer can use other pins to talk to whatever it wants. So when I get into OBD2 a little bit, we're going to break down what OBD1 is, what OBD2 is, and what just not OBD is, but it still has a 16-pin connector. So we're going to break down what actually makes OBD2 because it's real specific what makes OBD2. It comes down to when I have to set a code, how I have to react, what monitors do I have to have, how do I have to monitor the vehicle. So Yaman, you have a question.
Yeah. If we're testing a module and the module is bad, the only thing to do is to replace it, right? You can't fix modules.
Correct. I'm going to hesitate on that. You can't fix modules. There are shops and places that do fix some of the modules. Sometimes it's just an analog to digital converter or a transistor that's gone bad or a driver. But there you're moving from auto repair, which we do, into electronics. So in the field, we really don't replace. All we do is replace modules. We don't repair them. But there are rebuilders out there. Some of them are specialized. Like there's a guy on the East Coast. I think he's in Delaware. All he does is Mercedes modules. There's other people that are more universal that they do a lot of different kinds of modules, but they only do powertrain control modules or transmission control modules. So it really kind of varies, but that tends to be a specialty. But that's definitely a market within the automotive industry.
I see.
People have taken their electronics knowledge and then their automotive knowledge, combined the two, and made a company. And there's several of them out there. There's certainly room for more that rebuild computers and send them back. So in the shop, we're doing it on an exchange basis, but there is a market for that. And again, one reason why the guys specialize in Mercedes is some of those modules are $3,500. So if you're selling a rebuilt one for $1,000, that's a great deal. So even if it's taking you a fair amount of time investment to learn how to do it and a fair amount of money, there's a good payback for it.
Yeah, and I see a lot of people use they send out the SRS module and have it reset or something? Is that also a thing?
Yeah, what they're doing is an SRS module has a flight recorder in it.
Yeah.
And what some people are doing is they're sending it out and they're basically wiping the memory of the flight recorder, which I think is technically illegal, but it doesn't stop anybody from doing it. And again, it's cheaper than buying a new module.
Yeah. Okay.
But so yeah, but someone basically hacked into it, figured out how to do it, and figured out how to reset them. So instead of buying a new $300 module, I'll recondition yours for 80 bucks or 125 bucks. So you can see a lot of the effort is in the learning how to do it and setting up. And once you do it, you're going to see a lot of the same thing over and over, and you get pretty proficient at it. And so no, there are companies out there that do it. And the great thing about the internet and the ability to ship stuff is you're not limited to just San Diego County or California. You can do things on a very large level. So that's, I mean, that is a neat thing. I've opened up modules and had to fix them on occasion, especially if I'm the one who's let the smoke out of them. And a lot of times you can actually look at the board and see where the smoke came out. And then if you have enough knowledge and are able to repair the board, you can either use a jumper wire if you Zorch the board, or replace the capacitor that exploded, or replace the transistor or voltage regulator.
This meeting is being recorded.
So does that answer the question okay for you?
Yeah, that's it. Thank you very much.
You bet. So on this picture, what I did over the next couple slides is I just kind of showed some different ways that these computers are networked. And you can see here, I just highlighted the purple. And what? This is actually a loop. It starts, if I go from here, I get my mouse over there, it starts from here, and it comes all the way up, and it goes all through here, all the way down and over. So on a system like this, where it's a chain, if this wire goes bad, I can't talk to the next two modules. Or if this wire goes bad, I can't talk to this module. That's pretty easy to diagnose. What's hard is sometimes we get codes in a network for a communication fault, like this wire right here goes bad. Well, if that wire goes bad, I can still talk to all these modules, but the modules are setting a code that there's a problem with the system. Many times those codes are ignored, and we don't end up addressing them until what? A second wire goes bad or something like that, because these have a certain amount of built-in redundancy when there's more than one road to get there. Just like when we're driving, if there's only one road to get to our destination, we're stuck on that road. If the bridge goes out, we're not getting there. And we know where the problem is. We know where the bridge went out. If there's two roads to get there, I can still get there. And a lot of times the codes don't tell me which way I couldn't get there or where the problem was. They just say there's a problem. And so many times those codes are ignored. So even though we clear them, they come right back, all the modules are working and the car has no drivability fault. Normally we don't fix those because A, the customer doesn't want to pay the money for us to find something that they're experiencing no issue, and those codes will not turn on the check engine light, so it's not going to interfere with getting a smog. That'll only create a problem when you get the second fault, and now the system doesn't communicate because we have two broken wires in the same network. And you can see here, I just kind of expanded out a little way. Here's a different way of drawing it. So just like we used a highlighter in some other exercises, we'd use a highlighter here to figure out the different topography or the different modules and how they're connected. So if I have some modules that aren't talking, by doing this, I could isolate where the problem has to be electrically. From here, I would have to go look up where these components are on the vehicle and then figure out how I'm going to test it. But like I always say, if I can't figure it out up here, how am I ever going to figure it out on the car? So I need to be doing this before I ever go out to the car and start taking things apart. And you can see here, again, I'm just kind of showing some different ways we can navigate this. One is not more right than the other. I kind of drew some different lines through here to show the different ways these are connected and the different ways they share information. And this is just respective of where I need to do if I had a problem with this car, which is what I already did do. And we've actually taken one of these cars and I shorted the entire network and the dash looks like a Christmas tree. All the lights are lit up. Steering doesn't work right. Nothing works right. Car still drives and shifts fine because the engine and transmission have their own network. I couldn't talk to the engine or transmission, but they work just fine. So this is using a diagram here to look at my topography and kind of figure out how that is. Some scan tools actually give you that topography. This happens to be a Chrysler factory scan tool. The different colors detonate different networks. So you can see here I've got some blue and I've got some black. I got a couple different networks going on here. And this is a great chance to point out something that I'm going to get to shortly, is that I have a couple different modules here. One right here, and this is a main gateway module. See how it talks to the black network and the blue network on it? Can everyone see the difference in the black and the blue here?
Yes.
Yes.
Yeah, see the blue network here and the black network here. So this module is able to talk to that. And then you see a purple network between here and our diagnostic link connector where the scan tool would plug in. So this module in the middle is what's called a gateway module. That gateway module is a module that goes between different networks and then is able to translate, because different networks may use different protocols. So this guy is a gateway. He's able to translate. He's also able to share information between different networks. So for example, we may have something that I need information on that's in one network that another network might want that information for. So it allows me to go back and forth between those networks. Now this right here also allows me to tell me who's present, who has codes, who's okay. There's a lot of stuff as I scroll down, and in the bottom of this gives me the decoding for what all the different colors and everything mean, which really isn't important right now. I just wanted to show the difference in the topography. And I also have an SCM here, which is also able to act as a secondary gateway module. This is something newer Chrysler did. Chrysler only used to have one gateway module, and when that gateway module went bad, nothing really worked right, and you couldn't talk to it. Now we have a redundant gateway module with the SCM here. So now what? I'm able to share information two ways. So if one goes bad, I can set a code for the bad module, and then I can still get information shared, set the code. Everything can still work for the customer. We can keep emissions down, and then we can get that back in and repaired. So a vehicle may have more than one network system, true or false? So time to write that down. Was that question 4?
I thought it was 5.
It could be.
No, it's 4.
You guys are counting. You guys are writing them up. I'm trusting y'all on this.
All right, for sure.
Okay, everyone got it?
Yep.
All righty. So this is a 2005 Chevy Avalanche, and it came in as a no start with a lot of the accessories not working, like the power seat, windows, some other stuff. Now the car had an intermittent problem of this happening. The customer came in, the car wasn't acting up at the time, and we got a bunch of codes out of it, and the codes had to do with communication faults and some modules that it couldn't see, and we documented that. The customer didn't want to leave the car with us. The next day, the car would not start and got towed in. When we hooked the scan tool up, this is the message we got. No communication with vehicle, check diagnostic link connector, check ignition on or off. So if you notice, it's not saying check OBD2 connector, it's saying check diagnostic link connector. And we know that we could communicate yesterday and the car was starting, and now we can't talk to it and the car doesn't start. So it kind of makes sense that the not being able to communicate might have something to do with the car not starting. So if I can't communicate, the first thing I need to do is test my DLC. And when I go to my DLC, we can see here I have several pins. You guys already looked at 3 of those pins. You looked at pins 4 and 5, and they were what? What's on pin 4 and 5? You guys just had to use it for the memory.
Ground?
Ground. And what was pin number 16?
I was positive.
That's positive power. So I can see here in the picture, there is 4, there is 5, and there is pin 16. Now the other pin I'm hooked into right here is pin 2. So on this particular vehicle, it uses what's called a J1850 protocol, or GM calls it class 2, is their in-house name for it. But the actual protocol is J1850 by the Society of Automotive Engineers. So we used an adapter here because they didn't have a breakout box like we have at the school. They use an adapter here, which is a small spade connector that goes in and then has a test connector in the back to put the meter on. You never want to take your meter and shove that round meter into where that spade goes, because you'll open the pins up and then the scan tool won't work. So it's real important to do that properly. Now, when they hooked up, they looked for voltage here, and this is what they got. So if I look here, and I'm looking at the scope, and as I look at the scope here, we can see that I have 2 volts per division, where the 1 is my 0 volts. So if I come up 1 division, right to here, that's 2 volts, 4 volts, 6 volts, 8 volts, 10 volts. That'd be 12 volts. So are we good at calling that about 11 volts?
Yeah,
Yeah.
sure.
Does that work, 11 volts? Okay, so this is where it's important to know how things work. Because Mario, earlier you mentioned 5 volts, okay? So some systems work 0 to 5 volts, and we know that's not always 5 or always 0 necessarily. This system works 0 to 7 volts. So at rest, I have 0 volts. When someone wants to talk, it goes up to 7 volts. When they're done talking, it goes down to 0 volts. So it's 0 to 7. Well, if I'm moving something 0 to 7 volts, can we see that if I have 11 volts on the system the whole time?
Yeah.
How could I see it? Because isn't 11 more than 7 or 0?
Yeah.
Yeah. Oh, so you wouldn't be able to see it because it's only set to max 7, or?
Right. Well, what it is the computer's only looking for 0 or 7. Since 11 is more than 7, and since the computer puts 7 volts to try to talk, it'd be like me trying to talk next to a big speaker here. And my mouth's moving, but you're not going to hear a thing I say, because I'm being what we call jammed out. I'm being overridden because of all of the sound coming in. This case, all the voltage is more powerful, right? 11 volts has more energy than 7 volts. We're all good with that, correct? So if I've got 11 volts here, I'm not going to see that 7 volts. It'd be like taking a 12-volt battery and then putting a 9-volt battery and touching it to the 12-volt. And it's not going to change my 12 volts, is it? I'm never going to see that 9 volts. It's just going to stay 12. If I looked at the 9-volt side, I'd see it. The wires going to the 9-volt go higher on the outside of the battery. But I'm not going to change the voltage we see in the wire because it's already got that 12 volts. Same thing's happening here. Because I have that 11 volts there all the time, when a computer puts 12 volts or 0 volts on it, it can't see it because we're shorted to 11 volts. So that's what we're looking at here. So if I want to diagnose this, the next thing I need to do is figure out how it's put together. And I'm going to do that without going out to the car and taking things apart. I'm going to go get a schematic and figure out my topography or figure out how it's built. So here's the schematic for this vehicle. And in this case, it shows my diagnostic link connector right here. And that's pin 2 on my diagnostic link connector. I can see the other 3 pins I showed you, 4 and 5 go to ground, and 16 goes to power. So I can see all of that there. And from there, it goes over to a splice pack 205. So what a splice pack is, and GM uses these, some other manufacturers use these, is that's where a whole bunch of wires go together and they have a piece that drops in the top that connects them all. And GM calls it a comb because that's kind of what it looks like. It's solid on the back and has a bunch of fingers coming down and it plugs in and that jumpers everything so they're all connected in that splice pack. So that makes kind of a neat test point if I can get to that splice pack because I could what? Unplug the splice pack and test every one to see who has 11 volts. And that would tell me which of these is the problem, which is a lot quicker than what? Going and trying to disconnect every one of these computers you see to see if my 11 volts goes away or if it's in the wire going there. So we kind of want to divide and conquer. And that's normally how you do a network problem. So in this case, we're going to test the splice pack. So I have the comb removed. I'm in here with a meter touching each of these, looking to see if any of them have 11 volts. Because the 11 volts is at pin 2 of the DLC. As I back up, that pin 2 just goes to the splice pack. So either that wire is shorted to 11 volts somewhere, or it's getting 11 volts from one of the other wires. So if I disconnect the splice pack, we can see that. So we disconnect the splice pack and we pinned around through and we found that one of the pins had 11 volts. So now we're going to want to go back to the wiring schematic and see where that wire goes. So I went back to the wiring schematic and pin H is the pin that had the voltage, which is right there. And it goes, oops, to splice pack 206. So now I need to go back to my diagrams. You guys all hate it when I have you look up diagrams and stuff. The whole concept or reason why I have you guys do so much looking up is because that's how we fix cars and that's how we're fixing this one. You know, if you keep your head, stay relaxed and analyze, every one of you has the skills to fix this car. So it's just a matter of being relaxed and going through the process. So here we're going to go through, we're going to look at, it's pin H, which goes to splice pack 205. We located splice pack 205, which happens to be in the A pillar right next to the driver's door. And so we had to pull the paneling off, pull some stuff off to gain access. We got more money at this point. We stopped after our first test and had to get more money to start taking the car apart. But we went to the splice pack 206 and we found 11 volts on one of the pins. When we looked at it on the schematic, we saw the pin that had the 11 volts went to the driver's seat, to the memory seat module for the driver's seat. So, and we can see by the schematic, we have some connectors between the splice pack and the seat module. So this gives us a couple more test points to isolate this system. So what we did is we disconnected the module and we still had our voltage. So we started looking at connectors and we found an offending leg. And when we unplugged this connector, we no longer were shorted. So in the next picture here, you can see us wiggling the wires going to this connector because when we disconnected the module right here, we still had 11 volts. But when we disconnected it at this connector, we didn't have 11 volts, which means my problem has to be in this little harness between here and here. So we did some wiggling of wires and we did some other stuff, got it to come and go. And it finally made it necessary for us to take the connector apart a little bit. And they use retainers to hold all the pins in. And here's the retainer we took out. And see the nice little green there? That little green is corrosion. And that corrosion was between two terminals. Between retainer for pin 8, which is our class 2 data that should have had 0 volts, and pin 7, which is battery positive. So we're getting almost 90% of my battery voltage to go through that corrosion and get to the next connector. So once we put it all back together, we looked at our data like we did our first test where I had a straight 11 volts. And now my network looks like this, where it goes from 0 to 7 volts. And every time something goes to 7 volts, it's because someone's talking.
So if is that bad or?
This is good. This is known good.
Mm.
So this is what it should have looked like the first time we hooked it up, and we just had that flat line going across on the scope. So that's why we couldn't talk. Once it does this, we can talk to it with a scan tool. The car starts, everything works. So a lot of times people ask me, is it the repair or is it the diagnosis that's the expensive part? And I'll get to your question in just a second. Come on. You know, a lot of people say, well, gee, if I have you do the repair, are you still going to charge you for the diagnosis? Well, in this case, what do you think the customer should pay for? The repair, the diagnosis, or both?
Both.
Both.
Both, absolutely. And yeah, you got a question over here. Let me bring my mouse over. Yeah, what's the question, Yaman?
Brian, I have a question.
How did we know that it should go from 0 to 7 volts like that? Like, where do we get this information?
We got that information out of the repair information from the manufacturer. So I can get that on all data. I can get that out of specialized books or training like classes I teach. I could probably find it on the internet. I could find it on SAE because they have published documents for J1850 protocol on how it works. So the short answer is research. You could probably even Google it and get some information or some known good patterns on what a car that talks is supposed to look like.
Like how to diagnose the JB protocol?
Yeah, you know, how does class 2 data work? Because GM calls it class 2. And I bet you if I Googled that, I'd get some information.
Okay.
So, I mean, I can get it a lot of different places. I'm not trying to be vague. But what I don't want you guys to think is just because you're at home and you don't have Mitchell Identifix or all data that we have at the school, I don't want you to think that information is not available. We just got to get more creative at finding it. And someone else had a question.
Yeah.
Yeah, Alejandro.
So regarding the deep pinion and the retainer that you were talking about, the corrosion. I don't know if you remember when I asked you that I was doing this on my Honda Civic to do like a fuel injection. And
Yeah, the conversion. Yeah.
I had to like manually pin some of the connections on the ECU for the injector sequence.
Right.
And I hear you that you were talking about the voltage in the meter oscillation. Is this something that could affect the performance if the voltage reading is not within those specs?
Oh, absolutely. Yeah, all connectors, all circuits have a voltage spec and a parameter spec. If we're not in there due to corrosion, high resistance, induced voltage, induced ground, voltage drop due to a bad connection, the circuit's not going to work right.
And just to elaborate a little, because I know that before you mentioned that that having the like connecting the pin very close to the connection will heat it up and it could cause to damage it. Is that also a factor?
I'm not sure what you mean by very close to the connection. The pin needs to be fit correctly as far as the male and female parts. If that's loose, you'll get a voltage drop and you'll get heat also because you have resistance there. Is that what we were talking about?
Well, maybe I got this from Jackson's class, but like he was saying, if you shrink wrap it and solder it like very close to the connection, it could heat up the cable and damage it.
Only if you put excessive resistance in your connection. I've connected stuff literally this far from a connector because I couldn't get the new pin and I had to save it. I had just a little bit of wire, a 1/4 inch of wire coming out of the pin. and I either soldered onto it or used a crimp connector onto it and heat shrinked it. And I've never had a problem with loss or heat from that.
Okay, thank you.
You bet. Yeah, a lot of times when the rodents eat connectors or eat the wires off connectors, they don't leave anything. And some manufacturers only sell it as a whole harness. So it's $700 for a new harness plus about 6 hours labor. So you're talking, you know, $1,500 to a customer, or you pull it apart, pull the pin out, get a little bit of wire and start connecting things real close to the pin. I've had to do that a lot of times. I've never had to cause an issue. But good questions. So does it make sense to you guys how I got here as far as the diagnosis and how we could see that it's working and how I traced down that 11 volts just by using the schematic and then figuring out the topography of the network and just isolating it and checking one thing at a time to find out where it is?
Yeah, sure. That was a good case.
Okay. So, and again, it's just, networks tend to be really overwhelming. I have a lot of technicians that have been doing this 20 plus years, and I want networking classes. I have a networking problem. What do I do? It's like they're lost. It's like they forgot everything they ever learned. And it's just another electrical circuit. You know, it's more complicated than fixing a circuit with a single load because there's more to it, but we're going to use the same tools. So, Class 2 data network operates in what voltage range when it is toggled low and high? And I know I covered this, so time to wake up.
Um,
0.2 volts. Yeah, 0 to 2 volts.
Okay, so let's talk a little bit about CAN. You guys read an article on CAN. You've heard me brief CAN a little bit. I want to cover the twisted pair a little bit. I know the article talked about it some, so did the book. So all manufacturers now use a network system called Controller Area Network, or CAN, for OBD2 communication. That was required in 2008. So we saw a phase in of it in 2003. A couple Ford models, such as the Ford trucks with the 6-liter diesel, and some of the Ford Focuses started out with CAN. And we saw a slow integration of the industry over the next several years until 2008, when there's only 2 models that were sold on light-duty vehicles that did not use a control area network. One was the Chrysler Crossfire, and I can't remember the other one off the top of my head. And that's because they got an exemption because that was the last year that those vehicles were sold. So these are all, everything now uses CAN to talk to a scan tool, which is great because any scan tool I get today is going to be able to talk to anything that uses a CAN protocol. So I can talk to a Mercedes or a Maserati. It doesn't matter. I can talk to that OBD2 portion of the vehicle. Not necessarily all the modules, not necessarily the manufacturer side, but whatever's on that OBD2 network, which is probably going to be my engine, transmission, probably airbags, ABS, maybe instrument cluster. But some of them only have 1 or 2 modules on that OBD2 network. Other ones will have several modules. So it kind of depends on how they did the network topography. The advantage of the system is that all vehicles will have a standardized communication protocol to the DLC. So your scan tool will be able to communicate with this high-speed network system. So this is big. We see a lot more bidirectional controls, a lot more data because the system works a lot faster than the older networks did. So we can move a lot more information quickly. Also, the refresh rate, meaning the time that it takes my scan tool as a module to ask for information from the engine module and get the information back, is much faster. On an old system, say a European system using ISO 9141 like BMW, It could run 700 milliseconds to 1.2 seconds for my scan tool to ask for how hot the car is running, and the engine computer to come back and tell me how hot the car is running and give me a number. On my Toyota, it'll do that in under 50 milliseconds. So so at under 50 milliseconds, that's extremely fast data transfer. Matter of fact, my per PID rate's about 18 milliseconds on my car. So compared to these old systems that were the data was, yeah, this is what it was a minute ago, but it's not necessarily useful for fixing the car right now. It really is much better at what we have today as far as being able to use the scan tool and leverage the information we're getting to actually fix the car without having to go in and do further tests in many cases. And CAN is a big reason for that. So CAN bus wires are 2-wire configuration with a positive and negative wire. Each wire is capable of transmitting information. Matter of fact, they normally transmit the same information. The wire is twisted to reduce stray induced voltage signals coming from the bus wire adjacent high voltage systems such as your stereo, secondary ignition, coil wire starter. So we have different things on the car that we use a twisted pair for. CAN is one of them. A lot of sensors that use a permanent magnet or another. So a crankshaft sensor, some wheel speed sensors, other things. And they actually also use a twisted pair of wires to get rid of induced voltage or radio magnetic interference. The number of twists per inch on a twisted pair determines the frequency that it's designed to resist. So if I have to repair a twisted pair of wire, I need to look at how many twists there are per inch and try to get pretty close to that. If I'm a little bit off in one section, it's not the end of the world. But that's why it's twisted. It's twisted. It's not just the twist of the wire, but it's twisted at a certain number of twists per inch because they're concerned about a certain frequency range of interference. And so that's kind of interesting about twisted pair. There's actually a lot of science that goes into that and how many twists per inch. The control area network connects the bus. Our modules, most are programmable. These modules are small computers. So one thing the book did pretty good, and the book PowerPoint I'll talk about a little bit, is pass-through programming or programming modules. A lot of modules come what we call are dumb. All the hardware is there, but not the software, or just basic software, allowing it to get on the network. And then we actually have to hook a tool up, contact the vehicle manufacturer's website, and download the data for that to work on that particular vehicle as that vehicle is built. Because the first thing we need to do to have a network work properly is to have everyone on the network know who else is on the network. So if I just put a module in, it may not know that we have power windows. It may not know we have power seats or heated seats or dual zone climate control or any of these other functions. So I may be replacing a module that doesn't necessarily do any of those things, but it's not going to talk to any of those other modules unless I tell it that those modules are in the network. So sometimes it's just version coding, which we do a lot on European vehicles. And I can do that with a standalone unit. I don't need to call, I just need a factory scan tool or scan tool equivalent. And then other manufacturers, I actually have to go onto their website and download that information through the internet. So most modules can receive information packets off the bus, like sensor actuator information off ramps. Also send information packets like on ramps to travel the bus to be used by other modules. Using these modules eliminates the need to have large and expensive central computers. So these modules are allowed to share computing power. For example, my module going down the road, my engine control module is pretty busy, but my driver's door module probably doesn't have a lot to do. So it has the capability of performing certain computing tasks if other modules need extra computing power. They're able to put that out on the network and basically get other modules to do some of those computing functions. So we don't need one large central processor or one large central computer. We're able to use the entirety of the network to do more complex problems and put that stuff back. So it's really interesting how the networks are built. and how they're integrated. And that's why it's really important that when we change modules, it's the right module with the correct software. Going to the junkyard and plugging another module in, the system may not work or the network may not work properly, and we may have some real unexpected differences. Also, if the part number, even though the module looks identical, has the same number of pins, if the part number is different, don't plug it in. I learned that out the hard way on a Mercedes climate control module, and I'm here to tell you, you cannot unplug it before the smoke comes out. The smoke comes out really, really quick, and you cannot unplug a connector that fast. That's how I know I can fix a Mercedes climate control module. So we learn by doing, right, Mario? Okay, so what year was CAN required to be used on as the OBD2 communication protocol?
2008.
Well,
2008.
write it down on your sheet. What's this, question number 6 or 7?
6.
Okay. Okay, everybody got it? All right. So, I'm sorry, someone had a question?
Yeah, Mr. B, I think we got lost somewhere.
Oh no, sorry. I meant
Question eight.
we're out. That I'm good to move on.
This should be question 8, or the one we just had.
Okay. Yeah, I'm not counting, and I wasn't smart enough to put numbers on the questions.
Yeah, the one we just had about what year they can start.
Uh-huh.
That should be question number 8.
Okay. I thought we should have been higher than 6, but I lose track. So I appreciate that. Thank you, Keishan. Okay, since most modules are programmable and use a standardized communication protocol, they can be programmed to accommodate any new sensor, actuator, or component the manufacturer chooses to add during updates without extensive rewiring. So this is really important from a manufacturing standpoint. This allows me to build a vehicle platform, put a wiring harness in with maybe more connectors than I need, and then based on whether someone buys the deluxe version or the base version, that wiring's already there. It's just a matter of which modules we put in or which outputs we put in. So it allows them to, instead of making, 5 or 10 different wiring harnesses, depending on how the vehicle is going to be equipped, we can order one wiring harness. The same car gets the same wiring harness, means the colors are much more consistent. The wiring, the connectors are more consistent. The vehicle makes it easier to diagnose. And yet, as we move forward down the assembly line, maybe one of them is going to be a base model and one's going to be a loaded model. Maybe one's going to have power windows and power seats, but not have automated braking. So one's going to get the base braking unit, one's going to get single zone climate control, one's going to get dual zone climate control. But the magic of this is the wiring harness can be all the same. And then based on what modules we put in, how we program, and what they're hooked up to, as far as other things on the wiring, allows us to build a pretty consistent platform. The great thing for us is the connector locations and connector numbers are much more consistent among models. So if I'm working on a Camry, whether it's an SE, whether it's a LE, whether it's a LXE, C, any of those things, a lot of those connectors and wiring are all going to be in the same place. It's just a matter of which features did that car come with, which modules were equipped with that. And so that's a lot of why we have to program when we plug them in, because when we put it in, I needed to know which other features it has. So modules can be placed in various locations on the vehicle in close proximity to sensors, actuators, and components they serve. So instead of running wires from the back of the car all the way to the front of the car, why don't I just put a module in the back of the car and wire everything from my fuel pump to my fuel level sensor to my tail lights, to my brake lights, to my trunk light, everything into that rear module, and let that rear module control everything back there. And then I can get away with running 4 wires, literally, from the front of the car to the back of the car, a power, a ground, and 2 communication wires for the network. Because I can put a fuse box, I can put everything else back there. So you can see where we can really cut down and make things much more modular. So you can see where that really, becomes more efficient to manufacture, but from a diagnostic standpoint, it really compartmentalizes things. And it really means we're going to be using a scan tool to talk to these modules and look at our network when we're trying to diagnose a problem, instead of just taking a car apart the way I would have done 20 years ago. So we're really changing how we do that. Each module is programmed to emit its data using electronic code. That coded data packet is given priority based on how important it is to the operation of the vehicle. So some packets, again, are much more important than others. In order to know who to send messages to, I need to what? Know everyone's address. So that's part of that coding or programming function. So wires are used in twisted pair in order to prevent which of the following conditions from occurring. So I think this is number 9, right, Keishon?
Yeah.
Okay.
Actually, I think that number,
No, it's 7.
that
Okay.
number
It's question 7,
Yeah, that's
everybody.
question number 7 right there.
I'm on the 8, man. I don't know.
My
Listen,
God.
if
You're
whoever's,
advanced.
if you have another device, just pull up Canvas on a separate device.
Well,
Start at the
I'll go
10.
count them up. So hold on.
Thank you.
I'm on page slide 40 right now. So I got 1, 2, 3, 4, 5, 6. Now maybe I counted that one wrong. So hold on. 1, 2, 3, 4, 5, 6, 7, 8. This is number 9.
Serious?
What?
Yeah.
Serious?
Serious.
Why is
No,
the
I'm
we
other
see
kidding.
it?
I'm just making it up to make your head hurt.
What?
Can we
It's
see
okay,
it just
you're-
to make sure?
Don't worry about it. You're going to see all the questions again. So
We missed the 2.
I don't know how you did that,
Only have
but we got one more question, then you'll see all the questions. Okay, so here on a control area network, the engine coolant temperature sensor sends a low voltage signal to the module that's directly connected to it, indicating an overheating condition. Normally the engine control module, but it could be something else. That module converts the analog temp signal into a digital information packet to be sent out on the bus. The information packet is given a priority code. In this case, it is given a high priority code due to the seriousness of the message. Each module, commonly referred to as a slave module or node, is connected to a master module. The master module sorts the information packets on the bus and decides the order in which information packets should be sent via priority, like a traffic officer. So depending on the network protocol, most CAN systems don't work that way. Class C CAN, which we use for PCMs, we do still have a master module, which is one of the gateway module, and we have slave modules used for wake up, but a lot of modules are able to freely communicate with each other under the CAN protocol. Some protocols like LIN, they are not. That's a true master-slave relationship where they can't speak unless they're spoken to. And I'll show that towards the end of the PowerPoint when we come back after spring break. But it is in there. You guys can look ahead. Some of the slave modules are in sleep mode. The master module has to wake them up. That is true. And that's true with all networks, even class 2, where we have a master module responsible for waking up the sleeping modules. And we do that to cut down on the amount of current taken out of the battery when the car is sitting. It cuts down on parasitic draw. That way I only need to keep one module awake, and he knows if he needs to wake everybody up. So I only need to use enough energy to keep one module conscious instead of keeping everybody conscious. The reason they are sleep mode is to reduce the parasitic drain. Got that. Okay, master module, also sometimes called a gateway module. When the scan tools connect to a vehicle, the CAN is often only talking to the gateway module. We saw that on the Chrysler topography I showed you. we don't actually talk to any module other than the gateway module, and it translates into the other network and passes the information through it. To retrieve information the module the scan tool is trying to interrogate. The master module will wake up a slave module for the following reasons. Another module is requesting information that the sleeping module can provide, such as sensor actuator information. Another module is sending information the sleeping module needs, such as an actuator command, basically, hey, wake up, go do this. Kind of like when you're a kid watching TV and your parents woke you up to take out the trash. Or was that only me? Anyhow, the master module determined that more computing ability is needed to operate the vehicle, so it uses computing resources of sleeping modules to assist in carrying out difficult computing functions, an additional computer resource. There are 3 classes of CAN. There's actually 4 now, as defined by Society of Automotive Engineers, on the data speed of the bus, measured in kilobytes per second. CAN A, which is still used by GM for their non-drivetrain systems, and we actually have a trainer at the college that has that on it, is a very slow data transfer speed, about 10 kilobits or 10K. I remember how excited I was when I got a 14.4K modem because everything else was 7.2K. So there was a time when this was fast. Now, not so much. This is used on early vehicle systems, seldom used today. GM does continue to use this for their a lot of their body control stuff. CAN B is used a lot today, but not used for powertrain control systems. Medium CAN data transfer speed, about 83 to 125 kilobits. This class is used vehicle systems that don't require exceptional data transfer, such as body control module, HVAC, etc. CAN C is what our powertrain control module, transmission control module, ABS, airbag tend to all use CAN C. This is high-speed data bus of about 500 to 1,000 kilobits per second. This class is used predominantly for powertrain and chassis systems, receive high data speed. Electronically operated throttle, steering, brakes, etc. Usually the system only has 3 modules, but it can have as many as 7. So here's an example going from CAN A, where boy, we thought we were fast, to CAN B, which is still used by a lot of manufacturers. Like I said, GM still uses CAN A, to CAN C. Now we also have a CAN D. Now, if you work on Mercedes vehicles, Mercedes makes this really confusing because they title their CAN D diagnostic CAN B body CAN. So they're using different definitions than what SAE does. So like anything, we're looking at information, we need to figure out which language is being used. So Mercedes in their documentation makes it very confusing because they're defining these things differently. They're using different terms. So we do have CAN D. Yeah, go ahead.
CAN D is what, like a high speed, or that's like a special thing, or what?
Great question. That's why we're going to talk about it on this slide.
Okay.
So CAN A can also be called low speed CAN or LS CAN.
Yeah.
CAN B can also be called MS CAN or medium speed CAN. So some manufacturers just say, hey, this is MS CAN. They're not saying it's CAN B.
Okay.
CAN C is high speed CAN or HS CAN. CAN D is normally a flex rate or a MOST protocol. So we're not calling it CAN normally in those cases. Normally they're calling it a flex rate network or a MOST network, but those are a CAN D CAN. And you're at 1 to 400 megabits or megabytes per second. So that's faster than your internet is at home, potentially. So extremely fast. We normally use those systems for either advanced driver assist systems in the case of FlexRay, or infotainment system, which is MOST. And MOST is media oriented system transfer or something like that. but it is, media is in the name of most. It's specifically around infotainment. The book talks about Ethernet, which is a similar protocol to what we use in buildings. Some manufacturers are playing with Ethernet, but it's interesting, most is still gaining popularity. Honda actually went with a MOST network instead of an Ethernet network. MOST and FlexRay used to be strictly European protocols. GM uses FlexRay for their ADAS system. We're seeing Honda use MOST, so we're seeing these systems now come into Asian and domestic vehicles. Terminology gets a little confusing. For example, are we talking about can or can B, or C can or can C? We can mix and match how we see these things. Are we meaning the same thing? So sometimes I need to read the description and operation the manufacturer provides. For example, can high and can low, are we talking about the speed of the can, or am I talking about the can high, which is 2.5 to 3.5 volts, and can low 2.5 to 1.5 volts, or I'm talking high speed as in can C versus can low being low speed can A. So manufacturers interchange these terms, and it gets really kind of confusing sometimes. And that's why I bring it up, is not to confuse you, but to get you to ask questions on what am I actually reading, what am I actually seeing. So which of the following CAN protocols works at the fastest speed for integrating data? And I'm going to turn on polling because this is number 10.
Indeed.
It's A. Definitely A.
Okay.
100%.
Let's see here. Let me get to my polls.
So the most
Let me see,
networks
how do I
don't
get to
have
my other...
kilobit speed, Mr. Brown?
What's that?
So you were saying that the most networks don't have kilobit speed?
Most networks don't use the slower protocols anymore.
But they still have they don't have the kilobyte speed.
It's gonna,
Yeah, the
it's gonna be a
kilobytes is slower than megabytes.
Right.
Okay, I see what I did here. So I cancel that. I do this. Network part 1, launch polling. Okay, you guys should have polling. I'll give you guys a few minutes to answer all 10 questions on here. Everyone see the poll okay?
I got it.
Yeah, I got it.
So you guys can answer all 10 questions. And these are the 10 questions you guys should already been writing down the answers to, so it should go fairly quick. Not seeing anybody answering yet.
Where do I go? I don't know.
You should have a thing on your screen that either says polling or, because we did this the other day with one question.
I do
You
see
should
it.
be able to click on a question and it should let you come up with polling.
Oh, yeah, okay.
Or it's on the menu bar on the bottom. I don't see your screen, so I'm sorry, I'm a little... But we did the one question the other day and everyone did it, no problem. So I wasn't anticipating this today. There we go. A couple people are figuring it out.
Okay, I already submitted it.
I got 40 of us in here and only 7 have voted. So we got some room for you guys to participate.
So, Brian, what's the difference between B-CAN and CAN-B, or is it like the same thing?
Sometimes manufacturers will call it a B-CAN as being a second CAN, or like I was talking about GM, Mercedes calls it a B-CAN, meaning body CAN, not talking about the speed, where CAN-B is the speed. So some manufacturers really blur these lines. They don't stay consistent. with the naming or what it is. And when we look at computer systems, we'll really see that when we get into talk about pulse width modulation. A lot of manufacturers say they pulse width modulate stuff, and they don't. And it's a wrong term of the usage, a wrong term of what it actually is. But yet the engineers write it that way, so that's what's in the information system. I only got 15 of you.
And I also had a question on the previous slide you had before on the OBD2 one that well, you were saying it doesn't connect to all, like, you know, Mercedes and Maserati, or it doesn't all the components when you plug in the OBD2.
Well, that's true for a Honda or a Toyota too, but go on.
Oh, would you need like a different, or do they have like a separate DLC, or do you need some kind of
No,
like,
it's the same DLC. It comes down to addressing. So your scan tool is basically an address book. So the address book is limited on who it can, who it knows is there. It can only talk to who it knows. So if it wasn't programmed to know someone's there, it's not going to talk to them. And then it's also limited on which network it can talk on. So I mentioned GM uses a CAN, Class C CAN or Type C CAN network for its OBD2, where it hits the main modules, you know, airbag and so on. Then it has a completely different network that's on pin 1 of the DLC that talks to all of its supplemental stuff. And so if I'm using a generic scan tool, or a scan tool that only goes into OBD2, it's not going to talk to any of those other systems. So sometimes it's an addressing thing, and sometimes it's an issue of whether the it's on the correct network. So for example, Chrysler for years, we're up to 25, still waiting on 14 of you. Someone just left the room. For, as I said, for years, Chrysler used 2 different networks, whether I was talking to their car with a generic scan tool through the generic OBD2 side, or their ID'd it, told it, yes, I want to talk to this year, make, model Chrysler, and I have the software to do it. It went in through a completely separate network. So, and when I get into scan tools a little bit more, when we get into the computer control stuff, I'll expand on that a lot more.
okay, cool. Yeah, because I was wondering, like,
Still waiting on 14.
The class, question number 7, there is no choices. Like it says only 1, 2, 3, 4. So what?
There's only one answer for each one.
Yeah. Okay. Thanks. Sorry.
But you know, this kind of cool because you can see what other people are doing, just like we did in the classroom. I'm still waiting on, looks like 13 of you. So please get your answers in. This is also a way. Now, one of the neat things about the Zoom is it not only shows me how long each of you were logged into the class, it also gives me participation. In other words, are you interacting with the screen? And it actually gives that to me in minutes and percentage. So it's got some pretty cool stuff in Zoom. And this is another way that I'm able to use to actually show that, hey, you guys were here, since we're giving you guys credit for it. So it's important that you guys participate in the polls, especially since, you know, for the VA students, but really for everybody, because it shows that, yeah, I did actually put up with Brian 2 hours a day, 4 days a week.
Mr. Brand, I have a question while people
Sure.
are answering the questions.
Yeah.
These meetings are recorded, right?
Yes.
Can we review them later? Do we have access to that?
You do not. The system automatically cloud records. I need to look at the record and see, because I'm not sure how much they record. So I'm not opposed to making them available and do that, but I need to kind of look and see what it is. If it's just the screen you guys are seeing and all that, I think I can publish them and put them up on YouTube. And I saw a guy show how to do that. And so if I can do that, then I'll put them up as a YouTube thing, and then you guys can access them.
That would actually be really cool.
Okay.
If you don't want to like share them publicly, you can just make it unlisted and just give us the links.
Yeah, exactly.
Everybody else.
So if you guys are okay with that, I'm happy to do that. I thought about doing that. I've been playing catch up and trying to make things work. As you can see, my virtual reality screen still isn't working, and I found out my internet out in the shop is not quite enough to run everything I want to run. And all the cool stuff I wanted to buy, Amazon won't ship for a month and 3 days. So
yeah, tell me about it. Also, webcams are out, just like toilet papers. I can't find webcams anywhere.
Oh, I know. I was fortunate to get the ones I got because I drew it early, and I got some stuff I want to do. One of the things I got was actually a nice Canon video camera for actually doing some videos for you guys, and bought stuff for that. And then I also got a GoPro so I can do some stuff. So I've got software and learning tools to do. So, but yeah, I realized that I'm just a little bit short on having enough bandwidth to do what I need to do out there. So fortunately, I have another Wi-Fi router here. I'm going to try moving it and move that network closer and see if it'll do the trick for me. And just run a second network out in the shop. If not, I've got other options. I got friends of mine that do IT also. I might be able to get some stuff from. So, okay, so I'm at 30 of 39. So only 76% of you are voted.
Some people are having trouble with.
I saw a couple of you are having issues about not being. Okay, is there a trick to submitting it? Someone said that it didn't let them submit it, or it was resetting questions randomly. Did anyone have those issues and figure out what was going on?
No, I didn't have a problem.
Okay. Umberto said it finally let you submit. Did you do anything different, Umberto, or did it just seem to work that time?
It just seemed to work out of nowhere.
Okay.
Yeah, but it kept on, like, I would scroll down, and, like, as I was scrolling down, just jumped me back to the first question, but I don't know, it just started working.
Okay.
By itself.
So it's a work in progress. It only lets me do a total of 25 quizzes for my general meeting. So if I was to do these one at a time, I'd either have to, reload them every time, or I'd have to give you guys a new link address for a meeting every time to load them individually. That's why I'm trying to do them as a review. And this looks like it'll work pretty good because we're kind of going through this. Seems to be a good point in the class to be talking, and that way we can go over them. Give people another couple minutes to get them in, and then we'll go over. And I think this is going to get quicker the more we do it. And it is interesting watching the polling move here. Because you guys can't see what it is. You can just see what you're entering, right? Is that correct?
My screen, I'm still on the
Yeah,
camera.
that's correct. We can't see them.
Yeah, that's what I thought.
Are you saying we can't see the answers?
Yeah, you can't see what everyone else is answering. You only know what you entered.
Oh, that's not fair.
Well, no, because I'm going to show it to you in a minute.
Okay.
I know you guys. You see one person, everyone else would pile on, even if it's wrong. Okay, so we got everybody but 7 people got in. Is there anyone that wants me to wait for them, or should I go ahead and end the polling?
I'm having a hard time letting.
Okay, Bernadette, good. I'm glad you got it.
No, I cannot get it, sir.
Okay. We'll get it figured out by next time, I'm sure, because I'm sure the people that it worked for will talk about it, and we'll get it figured out. Let me go ahead and end the polling, and let's see. Let me share some results. So Everyone should be able to see the results now.
True.
Yes.
Okay, a network system can use a single sensor for many modules that need the same information. All but 2 of you agreed with me on that, and that's correct. Which of the following is an advantage of having a network systems on a vehicle? Less weight, better vehicle reliability, better fuel economy, all the above, and all the above is correct. Move this around a little bit. The information on network is carried in which of the following ways? Analog, digital, packet, or both digital and packet? And the correct answer is both digital and packet. It can't be analog because it's generated from a computer. So that's completely wrong. So 2 people picked that one. If you pick digital, you're correct. It's a digital signal. If you picked packet, you're correct. We mentioned packet in the PowerPoint on the slide. If you picked digital and packet, which 50% of you did, you put both of those things together, which is what I said, and you got the correct answer. A vehicle may have more than one network system, 91%. I could see getting 100% here are going to be just as hard as getting 100% in the other classroom. Another name for network structure is which of the following? And it is topography. I see where you guys got ring. That is a type of structure, so that's probably on me for making a bad distractor. So you were paying attention. I talked about ring networks, and that is, I had schematic before, and I changed that to ring, and obviously that wasn't a good choice based on the question. So I'm going to say you guys are both correct. Topography is what I'm looking for, but if you put ring, that's also correct because I did talk about how we form networks as a ring network, so that one's on me. Class 2 data network operates on what voltage when it is toggle from low to high, and that is 0 to 7 volts, and that's a little concerning. I think someone listened to someone saying 0 to 2 volts and thought they knew what they were talking about. And that's why I don't make it public till it's done, because, right, you guys are all going to chase after the first wrong answer sometimes. So it is 0 to 7 volts for class 2 data. The class 2 network uses how many wires for network communication? Only one of you got this right. It is 1 wire. How many wires did I have at the DLC? How many wires went to pin 2?
1.
1. What was I tracing? I was tracing 1 wire the whole time. So that one, not so much. Apparently I lost everybody but 1 person on that. So class 2 is a single wire network. Just like a lot of CAN A is a lot of single wire networks. Not all networks are 2 wire. What year was CAN required to be used on OBD2 communication protocol? And that, even though I need to fix the wording on that, 2008 is the correct answer. That's when it was required.
2008.
So why does it have 2 wires is right?
It doesn't. It just doesn't tag which is right. It just tags what the most people answered.
No, it actually tags
Oh,
what you
okay,
answered.
okay.
Or what people answer. Oh, yeah.
Yeah, because it's polling, not quiz. So the polling is you do a survey of the class, and this is what most of the class picked.
Got you.
And so I'm kind of adapting the polling that's on here to do the review questions that I normally put in the PowerPoints. So I'm working with what we got until I can figure out how to make it work better. And let's see, in what year was CAN required to be used? We got that. Wires are used as twisted pair to prevent which of the following? And the majority of you got that right, both induced voltage and signal noise. And which of the following CAN protocols works at the fastest speed? And 53% of you are correct. It is CAN D. So can is pretty simple. The earlier in the alphabet, the slower it is. So, all right. So A is slower than B, which is slower than C, and then D is the fastest. So I went through those. You guys all got the right answers for those. There will be a quiz. I'm not going to turn it on till after our spring break when we do the second half of this, because I have 7 more questions in this PowerPoint, and we'll do a 17-point review quiz. So make sure you guys document this.